Hey, what's up guys? Welcome to Developer. In this video, we are going to be diving into two C++ core concepts that everyone should be aware of. One being classes in C++ and another being something called as RAII. Well, what that is, we'll get to in later part of this video. Let's start with classes. Let's start with the basics of classes. So what classes are essentially a blueprint for creating objects. Classes define a custom data type. So the data types which you are aware of, int, float, maybe string. String is not a primitive, but it is in some kind of programming languages like Java and C Sharp. But a class is essentially bundling these different kind of primitives and maybe objects of other class as well, and then creating another data type of your own. It groups these data and functions together, functions which will be acting upon those data members. Let's start with actually how we create classes. So we start by writing the class keyword, and then we define the class name. So let's create a player class for the very basic example. And then what goes in is the access modifier. So there are three kinds of access modifier in C++: public, private, and protected. Albeit the least number of access modifiers are present in this language, but it does the job neatly. Um, However, no, will not be covering protected access modifier in this video. It is used in inheritance kind of scenarios, but for this video's purposes, we are going to be concerning with just the public and private access modifiers. So once you define the access modifier public, the public block starts. Here you can place functions as well as variables. The functions inside of classes are called methods because these are inside classes, so they are special. Special being because they are inside classes. So these functions are called methods. Let's declare just a few variables first. Name, health. We can also have a jump method. We will just print player name jumped. A simple jump method. We need to put a semicolon at the end of our class declaration. Now, declaring instances of this player class, or the objects rather, we do it in the same way normal variables are declared. So the way you declare an int, for example, int, the data type goes first, then the variable name, and then the initial value with which you want your int to be getting initialized. So that is how you declare a normal primitive variable. That's also pretty much how you declare a class, or an object rather. So you type in the name of your class, which will become the new type. So player is another new type which you defined, and then you name your player. So for example, I name the player Tom. What we can do now is we can assign these member variables some values. So tom.name, let's name it Tom. Tom.health, we can call jump method on Tom. The way we call jump method on Tom is also really very similar to how we initialize the variables. So Tom, and then we use the dot operator, and then we see jump. So we can call the jump method in this way. Let's just put in a breakpoint. Let's build this, press F5, and let's see what actually is happening. So we first get the player Tom. In the next line, we assign it a name, a health value, then we call this method jump. So if I step in, you see my control moves to line number 8, and then we can expect player Tom jumped to be getting printed on the console over here. Well, that was the basics of declaring a class. Let's move on and take things up a notch, shall we? Classes have special functions which are called constructors and destructors. These constructors and destructors are called during specific points during the lifetime of the objects of that class. So let me delete this player class and create another class. So let's have a ball class, and we define the public block. We can declare the constructor. So constructor is a special method which goes by the name of the class itself. It has no return type. Well, the return type is essentially void. You don't need to return anything from the constructor, and then you initialize your internal state of the class within the constructor. Let's declare an internal state first. So internal state refers to any kind of member variables you have. We can have a color. What we can do is print something onto the console. For example, color colored ball is spawn, and then we can assign color, let's say red. Now the way we declare these instances for ball class are going to be the same as we declared for Tom. Class name, then the variable name, let's name it ball. Let's have a method as well, void print details, stdc out ball is of color. Now we can call this method on the ball object, ball.print details. Let's build and run this. Since we didn't assign the color, maybe something is going on. Yeah, we didn't assign the color before we are outputting, so we need to move this line beneath it. We might also need to have adding a space over here. Let's build and run this again. Now we get red colored ball is spawned and ball is of red color. There are also something known as destructors. Destructors are another even more special methods than constructor, because constructors are of basically four types: default, parameterized, copy and move constructors. And where is that we put it tiled, and then the name of the class goes here, then takes in no parameters. It's an empty parameter list for this destructor, and in here you can deallocate or release resources for which you initialized during the constructor. So there isn't any real resource which needs to be deallocated over here. So what we will be doing here is just printing a simple message, so just so that we are aware that the destructor is getting called. Ball with color was despawned. Let's put all of this in anonymous scope. In C++ you can create scopes as such, unnamed anonymous scopes. It's perfectly fine, and it also helps us in identifying the actual lifetime of objects and seeing where actually the constructors and destructors are getting called. Let's build this application. Now let me put a breakpoint on this line number 20 and step inside the code. Alright, if I step in, you see we are inside the constructor, and on the left side you can notice the main function is underneath the ball constructor. So it's actually a function call, a real function call, which is getting pushed onto the stack. If we step in, we see color getting assigned to red, and then the log line getting printed onto the console. So we see red colored ball is spawned. Now if I move on, ball.print details. Now in line number 22, if I step in, we see the destructor getting called. As you can see on the left side on our call stack, main, and then the call to the destructor. This call is being performed by main. So it again essentially is a method call. Let's look at some other kinds of constructor which we can have. So the one which I just discussed is called the default constructor. There is another kind of constructor called the parameterized constructor. There is another called the copy constructor, and then there is another which is called the move constructor, which we'll be discussing in some other video when I discuss about move semantic. We'll leave that for some other day. So that will come after we discuss L values and R values. So stay tuned to the channel for that. Let's take a look at parameterized constructor. Parameterized constructor is just a function call which takes in some parameters. As you saw, default constructor was taking in nothing. Well, in parameterized constructor you can provide some parameters, some arguments to be taken in for initializing the state variables. For example, color in our case. We can take color from the user. We would want our client code to be ideally assigning the color to us if they want to. If they don't want always the red balls getting instantiated in this scene, we can take in a color and we can initialize it as such: color ball color. So what we have done over here is initialize the color variable using something known as a member initializer list. We could also have done this is perfectly valid, but as I said, constructors are special. Well, there are bit more specialities associated with these constructors. They have some special syntaxes. There are subtle differences between the assignment of color to ball color when done in a member initializer list versus inside the body of the constructor. We'll discuss these differences later when we move on to some other videos in this channel. We can also print a message, stdc out parameterized constructor called. Now coming to the copy constructor. Well, the copy constructor is again a very simple constructor. We take in a ball reference other, and what we do inside is we create our own member variables, substituting like for like. So other dot color becomes our color. Here and we can have a log line with copy constructor called. The way we were creating ball like this is a default constructor way of initializing the ball. We can, let me first rename this to ball1. We can create balls using the parameterized constructor as such. We can put in colors like blue. We will use the copy constructor and create a new ball from the blue ball. So this is a new ball which we are creating from the blue ball. This looks very much like a method call or a function call. We provide in the arguments by starting a parenthesis just after the variable name. You can actually visualize the copy constructor to be a type of a parameterized constructor where the only parameter is the object itself taken in via a reference. You can also take it via a const reference, but well, in this case, it doesn't make a difference. Now we can also call the print details method on the ball 3. Let's build our application. Let's press F5. We see red colored ball is getting spawned onto the console. We print details, ball is of red color. Now the blue color ball is getting created. We see parameterized constructor called. That's the log line which we were printing inside of our parameterized constructor. Now coming to the call to the parameterized constructor, if I step into this block, I see that we are getting inside of the parameterized constructor and we are logging parameterized constructor called to the screen. Now we print details of the ball too. Now ball is of blue color. If I step into this call to the copy constructor, we see the copy constructor is getting called. This is the line which is getting executed. Copy constructor call is getting printed onto the console. This is the point to note. If I step in, we are going to the destructor call. So we created 3 balls inside of this scope and every one will be invoking its destructor individually. Well, it looks like all these 3 balls were destructured in the opposite order of their creation. What we need to keep in mind about the copy constructor is that we are essentially copying resources by value. So we are creating duplicates. So keep in mind of calling the copy constructor wisely, because copying values is something which takes in memory allocation to be done again if you already had done it once. So that is something we should be wary of. Alright, now let's move on to what RAII is. RAII stands for Resource Acquisition is Initialization. Well, it's a C++ design pattern or an idiom which essentially means that we create resources in the constructor and we destroy them in the destructor. This is so that we ensure that the member variables lifetime are tied to the object's lifetime and inside which they are created. So you can consider the member variables to be sort of a child of the containing object, and everything should be destroyed inside the object. All of its state, its member variables should be getting released, deallocated in the destructor. Consider a smart pointer scenario where the unique pointer allocates memory inside of the constructor, the amount of bytes which you ask it to allocate for the type of unique pointer which you are creating, an int, custom user defined class, whatever. Then in the destructor, it actually calls free and releases that memory back to the operating system so that it is able to be reused again. Consider another scenario where like textures or materials inside of a game world are created. When a texture is created, an image is loaded into the memory, into the CPU memory, maybe inside of your RAM, and then it gets uploaded onto the GPU, the VRAM, and when the texture goes out of scope, when the texture is getting deleted, maybe that object on which that texture was applied, that player died or something like that, and then the memory should be released back from the GPU as well as the CPU. That kind of thing can happen in the destructor. So you would ideally be writing a texture class such that the allocations all happen inside the constructor and the releasing of memory on the GPU as well as the CPU all happen inside the destructor. Consider another scenario of having files. So file IO. You read the file or you write to a file, you create a file object of the standard if stream class, suppose, to read a file, and then in the destructor you close the file, which essentially closes the stream, deallocates all the control blocks whatever it has created for reading of those files, the internal states, the get and the put pointers, and a lot of other things. Essentially what I want you to understand with what RAII is and what it does is that it's a design pattern in C++, it's an idiom. What it says is that you initialize all your resources in the constructor and release them when you are done in the destructor. So what you write inside the destructor would be an exhaustive list of release operations. Alright, so I think I would stop here For now, I was thinking to create an RAII wrapper for a texture class, but I think that would be done in the next video. This video is getting too long. So see you in the next video where I'll be creating an RAII backed texture class where we'll be rendering a quad onto the screen with a texture applied onto it. So stay tuned for some graphics programming in the next video. Drop in your feedbacks in the comment section down below. Make sure to like this video if you liked it. Subscribe to the channel if you want to see more such content in the future and you don't want to be missing the video in which I'll be finally starting with some graphics programming, well, just for a demo of RAII. See you in the next video. Till then, keep on learning, keep on growing, keep making mistakes. Bye bye.